Alright, how's everybody doing out there today? This is Mr. Muscarella coming at you, and today we're going to take a look at graphing intercept form quadratic equations, and you will need to know that they take on the following form. F of x equals a times the quantity x minus p times the quantity x minus q. So that is the formula for intercept form equations. Now, the very first thing that you're going to want to do is find the x-intercepts, because they're going to be plucked right from the given formula. And to find the x-intercepts, you're just going to simply set x equal to p and x equal to q, and then of course we will write that as coordinates, p0 and q0. So once we've got those two pieces, we're going to go ahead and write that. The second thing that you're going to do is find the AOS. And the AOS is going to use this particular formula. And the formula is this. You're going to take x and set it equal to p plus q over 2, which basically is the average of p and q. So that's all you're going to do. And when you're graphing p and q, these two x-intercepts, if you think about x-intercepts where they are on a number line, one's here, this average is going to be halfway in between those two x-intercepts, those two values. So wherever p is and wherever q is, the AOS will be halfway between those two values. Now, after we get the AOS, whatever that value is, whatever that number is, the third thing that we're going to do is find the vertex. And to find the vertex, we're just going to substitute that AOS value that we got, whatever that axis of symmetry was, and we're going to put that into the equation right up here for x. So that number is going to go in for the x value. Then we'll simplify that and solve. So that's how you find the vertex, by substituting in the AOS value that we found previously. Now, once we get the vertex, the next thing that we're going to do is find the table of values. And the table of values, we're going to get that from the movement pattern. And again, that movement pattern is going to be 1, 2, 3, and that's going to be our left and right movements. And then our up and down movements are going to go with the squares of each of those numbers, 1, 4, and 9. Now, of course, this 1, 4, 9 pattern could change slightly depending on whatever your A value is. So you may have to multiply 1, 4, 9 by whatever your A value is to change that vertical movement. So 1, 4, 9 will be our vertical movement. And again, that's always, every time you're going to start that table of values, you're using that movement pattern, you're always going to go ahead and begin from the vertex. Now, after we've got all of our points plotted, we'll use those points to create our table of values right from our graph. Two more things that we want to do. Now, the increasing and decreasing intervals, parabolas or quadratics are going to have one of two shapes in the algebra 2 or below level. And right now we're just going to take a look at both of these two guys, where you're going to have either a parabola that opens up or a parabola that opens down. In either case, wherever our axis of symmetry is, that divides your parabola in half. And if your parabola is opening up, that side is going to be, the left-hand side is going to be the decreasing part. But if your parabola opens down, instead, that's going to be the interval where your parabola is going to be increasing. Now, with that, you're going to have from negative infinity, say our axis of symmetry is at the line x equals 2, then we would go from negative infinity to 2 for that interval, and then from 2 to positive infinity for the other interval. Now, on the right-hand side, if your parabola is opening up, that's going to be the increased side, but if your parabola is opening down, that's going to be the decreasing side. So increasing, decreasing intervals just depend on what direction your parabola is opening. The other thing you need to make sure that you do is whatever your axis of symmetry is, your AOS, that's the value that you're going to use for the number that goes along. The last thing that you're going to have to do is find the y-intercept. And the y-intercept, if you think about a graph, the y-intercept is going to intercept your y-axis somewhere along that line. So of course, when you do that, you're going to have the coordinates 0, y. All right, so to figure out what the y-intercept is, you're simply going to plug 0 in for x and write your solution as a coordinate pair. Again, your graph would have some point where the parabola crosses, and that would have the coordinates 0, y. Sometimes it's in the top part of the y-axis, and other times it might be in the bottom below the x-axis. So your y-intercept has the coordinates 0 and then y. Now let's go ahead and take a look at two examples that we're going to do to kind of put all of these pieces together. Now in our first example here, we're going to have y equals 2 times quantity x minus 3, x minus 1. So of course we're going to get after our x-intercepts first. All right, and to find your x-intercepts, you're going to take each one of those two factors that are in parentheses, those two binomials, and you're going to set each one equal to 0. And then solve it. So the first one you'll get 3, and then the second one, x minus 1 equals 0, you're going to get 1. So with these you're going to get the 0.30, and the other one you're going to get. So those two values right off the bat, you're going to take your x-intercepts and you're going to plot them. 30 is right here, and then 10 is right here. You're going to go ahead and plot those 2 points on your graph. Now, halfway in between them, if I look at the number that's halfway in between them, of course, we can kind of see where that is. It's really nice. That would just be this line right here at x equals 2. So x equals 2 is going to be my axis of symmetry, and of course I'm going to verify that algebraically by plugging it into that formula. So the AOS formula, what I'm going to do is take the two x-intercepts that I got, 3 and 1, and I'm going to add them together. So 3 plus 1 over 2. Of course, when we do our arithmetic, we get 4 over 2, and that's just 2. So my axis of symmetry does come out with a value of 2. Now that I know my axis of symmetry is 2, I've got to take that number, 2, and I've got to plug it into my equation anywhere there's an x. That'll give me the y-coordinate for my vertex. So to find the vertex, we're just going to plug that AOS value, x equals 2, in for y. So y of 2 is going to be 2 times the quantity x minus 3, but in an x's place, we're going to put that 2 minus 3, and then 2 minus 1. Now this is just straightforward arithmetic here, so just take your time and make sure that you do your arithmetic correctly, because that's where a lot of people will make a mistake. So 2 times negative 1 times 1 is just simply negative 2. So my vertex is going to have the x-coordinate 2, my y-coordinate negative 2. Now if I look onto my axis of symmetry, 2, negative 2 will be right down here. Now to come up with a table of values, I've got to pay really close attention to my a value, which in this case is 2. Alright, so since my a value is 2, normally when I take a look at my movement pattern, I would use the 1, 2, 3, 1, 4, 9 movement pattern. Alright, but since my a value is 2, I've got to multiply each one of those values by 2. So I'm going to have 1, 2, 3, but then 2, 8, and 18. So from my vertex, I'm going to go ahead and start moving, but I'm going to always start from the vertex. I'm going to go over 1, up 2. Well, look, that spot's already taken care of on the x-axis right there, my two x-intercepts. But I'm going to go back to the vertex and go over 2 to the right and up 8. So 1, 2, 3, 4, 5, 6, 7, 8. So the hardest thing here is just to make sure that you count right. Over on the other side, I'm going to have another spot. So those are the only 5 points that'll fit on the graph, and then what I do, of course, is I'm going to go ahead and connect those as best I can using some drawing skills here. So we'll go ahead and connect our parabola. Make sure you put arrows on the end, and that's that. Now to come up with a table of values, I'm simply going to go ahead and look at all of the points that are on my graph. So the very first point, when I take a look at that, so I'm going to write the TOV over here. Let's see, table of values. So my x and y coordinates are just simply going to come straight off of that graph. So I'm going to have 0, 6, and then I'm going to have 1, 0, and then I'm going to have 2, negative 2, which is my vertex. I'm going to have 3, 0, and lastly I'm going to have 4, 6. So all of those are my table of values. And again, notice how it's symmetrical. Now the last thing that I want to do is find my y-intercept. And for the y-intercept, when I take a look at finding the y-intercept, so let's see, I'm going to switch colors to this guy. We're going to go a little bit lighter. So my y-intercept, now I can actually see where that is on my graph. I get to 0.06. But if I want to verify that algebraically, so let me go ahead and get rid of all of this just so it's kind of out of the way here. We're going to go ahead and just do our arithmetic right now. And when we do that, we put 0 in for my x. So I'm going to have y of 0 is 2 times the quantity 0 minus 3 times 0 minus 1. And when we do our arithmetic, y of 0 is going to be 2 times negative 3 times negative 1. So 2 times negative 3 is negative 6 times negative 1 is positive 6. So I did in fact verify that algebraically the coordinates for my y-intercept are in fact 0, 6. Now the very last thing that we need to do are increasing and decreasing intervals, and since this is a parabola that opens up, the left hand side of my axis of symmetry is going to be the decreasing side, and the increasing side is going to be on the right hand side of the axis of symmetry. And again, we're going to go from negative infinity to the x value in my vertex, or the AOS, which is x equals 2. So I'm going to decrease from negative infinity to 2, because remember, think about it, that's going to have a slope, that side of our parabola is slanted like a downward slope, a negative slope. Now we're going to be increasing from 2 to infinity. Alright, so that's it for this example. We've gone ahead and we've labeled all the pieces. We've found points that are going to be on our parabola. We've listed a table of values, our vertex, our axis of symmetry, found our y-intercept, as well as our x-intercepts. We've also identified our increasing and decreasing intervals for this particular function. Now let's go ahead and take a look at one other example together, and if you think you have it, go ahead and do this example totally on your own, and then hit pause. And when you're done, come on back and let's see how you did. If you want to go through it together, here we go. First things first, find the y-intercept, or the x-intercept. So to find the x-intercepts, first, we're going to go ahead and set the x plus 4 equal to 0, and we're going to get negative 4 for that. And then we're going to set x plus 2 equal to 0, and of course for that you get negative 2. So these two coordinates are negative 4, 0, and negative 2, 0. And then of course I will plot those guys right over on my x-axis. So negative 2 is right here, and negative 4 is right there. Now what's really nice about this, again, we can kind of see from our picture halfway in between those would be this line right here, the line x equals negative 3. So my axis of symmetry would actually be this particular line, x equals negative 3. Now of course we're going to verify that algebraically, because we always want to practice our algebra skills when we do that. So our axis of symmetry, when we do that, we would take x, now negative 4 plus, and then negative 2. We're going to add those two together, divide by 2. Negative 4 plus negative 2 is negative 6, divided by 2 just gives us negative 3. So in fact, what we found graphically does match up with what we did algebraically. Boom, we're ready to roll. So we've got our axis of symmetry, we've got our x-intercept. Next step, give me the vertex. Somewhere on that axis of symmetry line is the vertex. So to find that, I'm going to take that value of 3 that I got from my axis of symmetry and plug that in anywhere there's an x. So go ahead and hit pause, do the arithmetic, then come back and let's see what you got. Alright, so how'd you guys do? Did you come up with the y-coordinate of 2, which gives us a vertex of negative 3, 2. So of course we're going to go ahead and plot that right on our axis of symmetry. So negative 3, 2, boom, right there. So now we know where that vertex is lying. Now the next thing we're going to do is we're going to plot the rest of the points, and to do that we're going to use our movement pattern. So normally we have 1, 2, 3, the first 3 numbers, and then they're squares, which 1 squared is 1, 2 squared is 4, and 3 squared of course is 9. Now since my a value is negative 2, I'm going to multiply 1, 4, 9 by negative 2. So when I do that, I will of course end up with negative 2, negative 8, and lastly negative 18. So I'm going to use those values when I talk about my movement pattern. So when we go to move and plot these other dots on our parabola, on our graph, we're going to start at the vertex. Remember, always start from the vertex. We're going to go over 1, down 2. Well, that is already taken care of by our x-intercepts right here. But I'm going to go back to the vertex, go over 1, 2 this time, but down 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's all the way down here and then down here. Because our parabolas are symmetrical, we're going to go ahead, make sure that you draw that appropriately, the lines on each side. Sometimes people make mistakes and one of the dots is off a little bit. So just take your time and make sure you do that. Then once we have all the dots there, we're going to go ahead and connect the dots, draw our parabola, and make sure that you put arrows on the end. So once we've got those dots drawn, from there we're going to go ahead and fill in our table of value. The TOV, you're going to start from that very first coordinate on the left, right here at negative 5, negative 6. So we're going to make our XY table, and negative 5, negative 6 is going to be our first point. Our second point is one of our intercepts, negative 4, 0. And then our third point is the vertex, which is negative 3, 2. And of course, we've got our other x-intercept 2, 0. And then lastly, we've got negative 1, negative 6. From here, one of the last couple of things I need to do is I need to find the y-intercept. And if I look on the graph, I can't see it in the viewing window that we are looking at, which means it's somewhere below negative 8. Where? Well, to find out, of course, we're going to plug in 0 for all of our x's to determine the value of our y-intercept. So go ahead and do that and then come back and see what value that you came up with by doing your arithmetic correctly. Alright, hopefully your arithmetic was good and you came up with a y-intercept of 0, negative 16. Now the last thing that we're going to have to do, boys and girls, is, what's that? Find the increasing and decreasing intervals, which, because our parabola is shaped upside down, will be the same for any parabola that is shaped upside down. Our increasing interval is going to be on the left-hand side of our axis of symmetry, and the decreasing interval is going to be on the right-hand side of our axis of symmetry. So the axis of symmetry, remember, x equals negative 3 is what divides those two intervals. So we're going to go from negative infinity to negative 3 for increasing, and negative 3 to infinity for decreasing. Alright, by now you guys should totally have down the ideas behind graphing in intercept form. Alright, thank you guys for watching today. Have a good afternoon, good evening, or good night. Peace out.